Okay, exponents and radicals. So if a is any real number and n is a positive integer, then the nth power of a is defined as this: a times more a's until you get all the way to the last a, and this is n factors, right? So a number a is called the base, and n is called the exponent. So a perfect example of that would be, how about 5 squared equals 5 times 5 equals 25, right? Or we could do, if we do it the other way, 2 to the 5th equals 2 times 2 times 2 times 2 times 2 equals 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2, the last 2, is 32. Right? Okay. So, what if we had to do something like 5 to the 3rd times 5 to the 2nd, or 5 squared? Well, that would be 5 times 5 times 5, that would be the first 3, times 5 times 5. And we could write that like that, actually. That might make it a little more readable, too. And what's that going to be? Well, we can write this as 5, 1, 2, 3, 4, 5. These are all going to be multiplied to each other. So we could write that as equals 5 to the 5th, right? So that means we could write it like 5 to the 3 plus 2, right? So let's see. That means we could, if we did that in with variables, let's say that we had a to the m times a to the n, right? Then we had equals a times however many a's there were to be m, right? And then a times however many there were in the n, right? So then we can just make that, let's start a new page here. We say that that is also equivalent to a to the m plus n, like that. Alright, so now we also need to know that the definition of a to the 0 always equals 1. We just define it as that. So we'll keep that in mind. But we need to look at other examples. So 5 to the 10th times 5 to the say negative 5 equals 5 to the 10 minus 5, which equals 5 to the 5th. Right? Or what if we did 5 to the 10th times 5 to the negative 10th, that equals 5 to the 10 minus 10, which equals 5 to the 0. So that equals, well, right here, 5 to the 0 equals 1. Right? Another way to write the negative exponents, we need to know that you can write 5 to the negative 10th. That equals 1 over 5 to the 10th. So if you have the negative, then you can just flip it over here and make that positive. So to make that to formalize that, we would say a to the negative n will always equal 1 over a to the n. Okay? So that, I think, we'll give you some examples. Let's do the laws. If you make sure we understand the laws. A to the m, a to the n equals a to the m plus n, and we'll say, you remember the example, so the way to think of it is that to multiply two powers of the same number add the exponents. And I've run out of paper, so